Quantum majesty is not just a phrase, it is an invitation to rethink reality itself. It speaks to a universe far stranger, more elegant, and more mysterious than anything classical physics ever imagined. When we look closely, beyond atoms, beyond particles, beyond even the idea of solid matter, we encounter a realm governed not by certainty, but by probability, not by rigid paths, but by waves of possibility. Imagine for a moment that everything you see around you, your hands, your breath, the air, the distant mountains, is not truly solid. At the deepest level, it is a symphony of vibrating quantum fields, flickering in and out of existence, dancing to mathematical laws that are both precise and profoundly abstract. This is the stage of quantum majesty. In the early 20th century, scientists began to uncover cracks in the classical worldview. Light, once thought to be purely a wave, behaved like a particle. Electrons, expected to orbit neatly like planets, instead smeared themselves into clouds of probability. The deeper we looked, the less intuitive reality became. Yet at the same time, the more beautiful it appeared. Quantum mechanics emerged not as a tidy theory, but as a revolution. It challenged the very foundations of how we think about existence. One of its most striking principles is superposition, the idea that a system can exist in multiple states at once until it is observed. This is not just theory, it is experimentally verified. A particle can be here and there, moving and still, existing in. But what does it mean to observe? In quantum physics, observation is not passive, it is an interaction. When we measure a system, we do not simply reveal its state, we participate in shaping it. This leads to one of the most profound questions in all of science. What? Closely related is the phenomenon of entanglement. When two particles become entangled, their properties become linked in such a way that measuring one instantly influences the other, regardless of distance. Even if separated by light years, they behave as a single system. This spooky action at a distance, as Einstein once called it, has been confirmed repeatedly. Entanglement suggests that the universe is not made of independent pieces, but of deeply interconnected relationships. At a fundamental level, separation may be an illusion. The cosmos could be more like a web than a collection of isolated objects, a vast, interconnected structure where information flows in ways we are only beginning to understand. And this is where quantum majesty truly begins to unfold, not just as a scientific framework, but as a philosophical awakening. In recent decades, quantum theory has moved from abstract mathematics into real-world applications. Quantum computing, for example, harnesses superposition and entanglement to perform calculations far beyond the reach of classical machines. Instead of bits that are either 0 or 1, quantum bits, qubits, can be both at once, allowing for exponential complexity. Though still in development, quantum computers promise breakthroughs in fields like cryptography, medicine, climate modeling, and materials science. Problems that would take classical computers thousands of years may one day be solved in minutes. Quantum communication is another frontier. Using entangled particles, researchers are developing systems that could enable ultra-secure data transmission. Because any attempt to intercept the information would disturb the system, such communication could be fundamentally tamper-proof. Yet, despite these technological advances, the deeper mysteries remain unsolved. What is the true nature of the wave function? Does it represent reality itself, or merely our knowledge of it? Why does measurement collapse possibilities into a single outcome? Is there a deeper theory beneath quantum mechanics, something more complete? Some interpretations suggest that all possible outcomes actually occur, each in its own branching universe. This is the many worlds interpretation, where reality constantly splits into parallel timelines. In this view, every decision, every interaction creates a new version of the universe. Other interpretations propose hidden variables, underlying mechanisms that restore determinism. Still others suggest that consciousness plays a role, though this idea remains controversial. What is clear is that quantum mechanics does not merely describe a strange corner of physics, it challenges our most basic assumptions about existence. And perhaps this is why it feels majestic, because it forces us to confront the limits of human intuition. It reminds us that reality is not obligated to conform to our expectations. It invites humility, curiosity, and wonder. Quantum Majesty is also a story of precision. Despite its abstract nature, quantum theory is one of the most accurate scientific frameworks ever developed. Its predictions have been confirmed to astonishing degrees of accuracy. The equations may seem abstract, but they describe reality with unparalleled fidelity. This dual nature, mysterious yet precise, abstract yet practical, is part of what makes quantum physics so compelling. As we move further into the 21st century, new discoveries continue to expand our understanding. Researchers are exploring quantum gravity, seeking to unify quantum mechanics with general relativity. This could lead to a deeper theory of space-time itself, where space and time are not fundamental, but emergent. There is also growing interest in quantum biology, the idea that quantum effects may play a role in living systems. Some studies suggest that processes like photosynthesis, bird navigation, and even smell may involve quantum coherence. If true, this would mean that quantum phenomena are not confined to laboratories or extreme conditions, but are woven into the fabric of life itself. And so, quantum majesty becomes not just a description of the microscopic world, but a lens through which we can view everything, from the smallest particles to the largest cosmic structures. It invites us to see the universe not as a machine, but as a dynamic, evolving system of relationships. It encourages us to think beyond rigid categories, to embrace uncertainty, and to find beauty in complexity. In a way, quantum physics mirrors the human experience. We are not fixed entities. We are constantly changing, shaped by interactions, defined by probabilities. Our lives, like quantum systems, are full of possibilities, paths not taken, outcomes not yet realized. And just as observation influences quantum systems, awareness shapes our perception of reality. What we focus on, what we measure, what we value, all of these influence the world we experience. This does not mean that reality is purely subjective, but it does suggest that our role within it is more active than we once believed. Quantum majesty, then, is not just about particles and equations. It is about perspective. It is about recognizing that the universe is far more intricate, more interconnected, and more surprising than we can easily comprehend. It is about embracing the unknown, not as something to fear, but as something to explore. As we continue to push the boundaries of knowledge, we are likely to uncover even deeper layers of reality. New theories, new technologies, new insights will reshape our understanding once again. But perhaps the greatest lesson of quantum majesty is this: